In this video, I'm going to present about Lab 2 and we'll start with question 1. This is a program where we do arithmetic equation coding in assembly language. So in dot data, we have two variables. The first is var1, which is a word size variable. It holds the value 1. And var2, which is also a word size variable, and it holds the value 9. In the dot code part, we have in line 16, what we do is that we move the value from the var1 into the register AX. And line 17, we move the value of var2 inside the register BX, and we exchange the value between register AX and BX, and then we move this value back to their respective variable. So I'm going to rebuild this program and then set a breakpoint here, and we'll need to debug. In this window, we can see the current value of in the register AX and the register BX, var1 and var2. So var1 is currently 1 and var2 is 9. Now I'm going to press F10 to step over. So after the execution of line 16, we move the value from var1 into AX. So now AX will equal to 1. And then moving on to line 17, we move the value bx, we move the value var2 9 into the register bx, so now bx will equal to 9. Next, line 18, we exchange the value between ax and bx, so now ax is equal to 9 and bx equal to 1. And the next is we move the value ax back into the variable var1, so now var1 equal to 9. And then next line, in line 20, we move the value from the register BX back to var2, so now var2 equal to 1. And then we can check here in the memory. So for var1, it is now 9. And then for var2, it is 1. That's it for question 1. Now we're back with question 3. In this program, we're going to do arithmetic expression. So in the dot data, we have 4 variables. For var1, we have 5, var2 is 10, and var3 is 20. And for var4, we don't have a value for that, and they're all D word. So now I'm going to build this. And next, debug. As we can check in this window, var1 is 5, var2 is 10, var3 is 20, and var4 is 0. And ax, we don't have a value for that yet. And let's press F10 and debug. So in line 19, what we do is that we move the value from var1 5 into ax, so now ax equal to 5. And next, line 20, we multiply the value of ax with var2. So basically, we multiply 5 with 10. So now ax store the value of 50 in decimal or 32 in hexadecimal. Next, in line 21, we add the value of var3. We add 20 to 50. So now ax equal to 70 in decimal or 46 in hexadecimal. And in next line, so line 22, we'll do decrement by 1. So the value of ax changed from 70 to 69 in decimal, or now is 45 in hexadecimal. And that's all for question 3. And now we're back with question 5. In this program, we don't have any data, or we don't have any variable inside the dot data. Hence, we are going to focus on the register DX, AX, and CX, and how to manipulate the value stored inside these registers. So let me build this. and then debug. And as we can see here in the first window wash one, since we have no variables, so we don't have anything inside this window, and we are going to focus only at this autos and registers. And now let me step over. So after the execution of line 15, we moved the value of 0 into dx. We cleared all the data here in dx. So now dx equal to 0, 0, 0. And since we are using dx, so we're going to focus only at the lower nibble of each of this register, which is the last four digits here is 0, 0, 0. And then next, we move the value 1000 hexadecimal into AX. So now AX equal to 1000, or this value right here in decimal. And then next, line 17, we move the value 25 into CX, or 37 in decimal. And then next, we multiply CX with AX, and that value is stored inside AX. So since 25 multiplied with 1,000 is 25,000, and that's not enough space to store 25,000. There's an overflow. So inside AX, we only store 5,000, or the last four digits of the product, and the 2 is stored inside the X. That's an overflow, or is stored inside the X, or there's a value here in AX in decimal. And that's it for question 5. And that's all for the lab presentation of lab 2.